Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hello, thank you for joining us on our Microsoft Virtual Training Day. Welcome to AZ-900. I'm Alexandra Zakharova, a Microsoft Technical Trainer, and I'm delighted to be your instructor for this course. The AZ-900 Azure Fundamentals exam presents a valuable opportunity for you to demonstrate your knowledge of essential cloud concepts, Azure services, Azure workloads, security and privacy in Azure, as well as Azure pricing and support. I want to emphasize that this is a foundational course, so our main goal will be to introduce various concepts. If you plan to take the AZ-900 exam, which I hope you will, you won't need to implement any of these concepts through the Azure platform. Instead, you need to be able to identify and describe the core concepts. To earn the certificate, you will need to score a minimum of 700 out of 1,000 possible points during the test. But don't worry, I will be here to provide you with various tips that will hopefully help you in your studies. One of the biggest tips I can give you is to take advantages of the free learning pass on the Microsoft Learn website. This course, including the slides I'm using today, aligns directly with Microsoft Learn. You can find the Learning Pass by following the link on the screen, aka.ms/AZ900. I strongly recommend bookmarking this page. It contains all the materials we cover. The AZ-900 course has 6 sessions divided into 2 parts. In our first part, we will start with the first session, focusing on the basics of cloud technology. In the second session, we will discuss Azure architecture and Azure Compute Services. And then we will finish our first part with the third session dedicated to Azure networking. After that, we will begin the second part of our course with the fourth session, which covers Azure storage. Our fifth session will be about identity, access, and security in Azure, followed by our final sixth session, where we'll explore Azure management groups, compliance, Azure resource management, and Azure monitoring services. Again, all the material we are going to cover during these 2 sessions is available on the Microsoft Learn website. Let's continue and start with the first session where we'll describe the core principles of cloud technology. Specifically, in our first lesson, we will cover cloud computing, the shared responsibility concept, cloud models, capital expenditure, and operational expenditure. In the second lesson, we will discuss the benefits of cloud technology and conclude the session with a description of various cloud services. If this is your first encounter with the cloud, don't worry, it's going to be great. We'll cover the general terminology of the cloud computing using common terms used by various cloud service providers in the market. Now, let's get to the most crucial part, defining cloud computing and its purpose. Nowadays, almost everyone uses cloud technology. When I say everyone, I mean restaurants, medical center employees, banks, logistic workers, human resources, hairdresser, and so on. Basically, anyone dealing with programs or services over the internet. Even my grandmother recently asked me what I do at Microsoft. And when I told her that I teach cloud technology, to my surprise, she said she knows what cloud is. I asked her to explain, and she said it's where she stores all her photos. So what exactly is cloud computing? Cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resource allocation, and cost efficiency. When you leverage the cloud, you essentially rent infrastructure from cloud provider, including compute, networking, and storage resources. To better understand these components, let's draw a parallel with the function of the human body. Computing can be compared to the brain. It's the central processing unit where all operations take place. Networking, on the other hand, can be likened to the circulatory system responsible for the flow of information and communication, similar to our limbs that facilitate movement. Lastly, storage can be seen as a warehouse or a library, acting as a repository for storing and retaining data and information. Much like how our stomach digests and holds nourishment. These resources are hosted in data centers located worldwide, operated by a third-party organization. As a customer, you have access to leverage these tools and capabilities. Gone are the days when owning your own data center was the only option. The cloud provides flexibility and accessibility. It caters to businesses of all sizes, not just large corporations. The cloud offers multiple benefits, including financial advantages and reduced maintenance overhead. By utilizing a cloud provider, you can focus on your core business objectives, instead of dealing with the complexities and costs associated with maintaining your own data center. Let's deep dive the different model of cloud computing. What are cloud models? The cloud models define the deployment type of cloud resources. The three main cloud models are private, public, and hybrid. Let's explore the private cloud. It refers to a single organization having complete control over its infrastructure. This means they are responsible for all the hardware. Only that organization has access to the services and resources provided. As the saying goes, with great power comes greater responsibility. And this holds true in the case of the private cloud. While you have control over your data and can determine who accesses it and how, you can also have the burden of high overhead costs. Additionally, technical expertise is required to handle tasks such as ordering, setting up, and maintaining the infrastructure. In the private cloud, you are accountable for fixing any issues that arise, as there is no panic button to rely on. Despite the challenges, there are benefits to the private cloud. For instance, you don't need a public connection to access your data. You can establish a completely private network for accessing your resources. As the owner of a private cloud, you maintain control over all aspects, from determining who has access to your data to deciding how it's managed. However, it's important to remember that with this control comes the responsibility to address any problems that arise. If you make a comparison, the private cloud can be likened to owning your own car. You have the freedom to manage it according to your needs and preferences. However, it's important to note that owning a car requires maintenance and can be more expensive than using public transportation. Now, many people may think that private and public clouds are completely opposite. However, the truth is that they share many design principles and technologies. Let's delve into the details. A public cloud is like a bus or subway system. It's built, controlled, and maintained by a third-party cloud provider, allowing anyone who wants to purchase cloud services to access and use its resources. Just like public transportation, the public cloud is open to everyone. Users can easily hop on and hop off whenever they need, paying for the distance they travel it based on their specific stops. One of the main advantages of the public cloud is that the users are not responsible for its maintenance. They can simply utilize the services without worrying about infrastructure management or hardware upkeep. It's similar to how passengers on a bus or subway don't have to worry about maintaining the vehicle or the tracks. Another parallel between the public cloud and the public transportation is the ease of access. No significant licenses are required to use the public cloud. Similarly, when boarding a bus, you don't need a specific license to do so. The public cloud allows individuals and organizations to quickly leverage its resources and services without extensive setup requirement, just as you pay for public transportation based on where you boarded and where you go out. The public cloud operates on a pay-as-you-go model. Users are charged based on their usage, whether it's the amount of storage used, computing resource consumed, or data transferred. So, when thinking about the public cloud, envision a convenient and accessible system, much like taking a bus or subway. It offers flexibility, scalability, and cost-effectiveness for users, enabling them to leverage cloud resources without the burden of infrastructure management or complex requirements. Now, let's discuss the hybrid cloud, which combines the best of both worlds. Think of it as having the option to choose between a bus and a car depending on your needs. The hybrid cloud allows organizations to leverage components of public cloud while maintaining control in the private cloud. For instance, let's consider an accounting firm or a medical office that needs a public-facing website. They can utilize the public cloud to host their servers for the website, ensuring speed and accessibility. At the same time, they can connect that website to a secure database in their private cloud to comply with data governance regulation. The hybrid cloud offers flexibility tailored to different organizational needs and preferences. Keep in mind that every organization has unique requirements, and hybrid cloud provides solution and flexibility like no other option out there. If we return to our analogy, considering that I live close to Paris, there is often significant traffic in the city center during the morning. Given that I live outside the city, I have the option to drive to the train station and then utilize public transportation to reach the city center. This involves combination of two approaches, using a private car and relying on the public transportation. As we continue our journey today, we will explore different terms and scenarios where one cloud model may be more beneficial than the other. In the table on my screen, several key aspects of comparing different cloud models are presented. Public cloud saves us money, as we only pay for what we use. All programs and applications are installed quickly. In the private cloud, everything is much more expensive from the beginning because we must buy our own equipment, ensure its security, and not forget about maintenance and updating our applications. Finally, in the hybrid cloud, we have the flexibility, as it allows us to decide where to run applications and how to control security. To remember these three terms for the exam, you can use our analogy with different modes of transportation. Now, turning our attention to cloud models, we have covered a lot of ground. However, a pressing question arises. Alexander, how does the payment structure work? And this is where the cloud truly shines as an outstanding solution. When we delve into cloud expenses, we can approach it from two distinct angles. To illustrate, let's consider a scenario. Imagine my online business involves selling flowers. I'm looking to quick start a website and I'm considering local hosting. In the context of a private cloud model, getting started will entail an upfront investment. I would have to acquire a server rack, cables, wires, and all the essentials to launch. The initial investments can be substantial. However, over time, assuming my demand remains relatively steady, my physical infrastructure cost will taper off. While the upfront expenses might be significant, it's important to remember that this isn't a recurrent monthly cost. The assets are now under my ownership. On the flip side, if my business expands and scaling becomes necessary, I will need to invest further. What I have just described is known as capital expenditure, or a CapEx model. In this model, you front-load your expenses, creating a financial burden. While it's true that you won't encounter additional charges, since you have paid it upfront, you are exposed to the risk of depreciation and obsolescence. Similar to purchasing a laptop today, only for it to be outdated next year, or buying a brand new car that loses values once it leaves this lot. Technology follows a similar trajectory. In contrast, OPEX is spending money on services or products over time. Renting a convention center, leasing a company car, or signing up for cloud services are all examples of OPEX. It operates on the line of operational expenditures. This approach holds immense value, as it supports a pay-as-you-go philosophy. You get what you need right away and are billed only for the products and services you actively utilize. Cloud computing falls under OPEX because cloud computing operates on consumption-based model. With cloud computing, you don't pay for the physical infrastructure, the electricity, the security, or anything else associated with maintaining a data center. Instead, you pay for the IT resources you use. If you don't use any IT resources months, you don't pay for any IT resource. Now let's move on to the various advantages of the cloud. When deploying application, services, or any IT resource, it's essential that these resources are available when needed. High availability is designed to ensure maximum accessibility regardless of possible failures or other events. When developing a solution, it's crucial to consider the services availability guarantees. Azure provides a highly available cloud environment with uptime guarantees based on the specific service. These guarantees are part of the service level agreements, SLAs. Another significant advantage of the cloud computing is the scalability and elasticity of cloud resources. Scalability allows you to adjust resources to meet demand. When sudden traffic spikes and system overload occur, scalability enables the addition of extra resources to efficiently handle the growing demand. Elasticity, on the other hand, allows for automatic scaling. Scalability generally comes in two forms, vertical and horizontal. Vertical scaling involves increasing or decreasing resource capabilities. Horizontal scaling involves adding or removing resources. To explain simply, think of a virtual machine. Let's say I have a virtual machine and it currently has 4 GB of RAM. Based on analytics embedded in Azure, my manager tells me, Alexander, 4 GB are not enough for our current needs. We need to increase its size. So what I do? Well, I scale this machine up to 12 GB of RAM. But guess what? New analytics reports come in and my manager says, Alexander, we went too far, 12 GB are too much, we can save some money if we scale down to 8 GB. And this is the perfect number for our virtual work environment. So I scale it down to 8 GB. Regarding horizontal scaling, let's say for the task I need to perform, one virtual machine isn't enough. I need to have multiple virtual machines running simultaneously. So I will scale to 2 or to 3 virtual machines. It's important to note that I'm using virtual machine memory as an example, but you can scale any other resource in similar manner. As you remember, I have already mentioned that elasticity is the ability to automatically scale your resources. Let's say you have a website for selling children's toys, and you can use automatic scaling to add more storage automatically during holiday period. Similarly, in the event of significant decrease in demand, deployment resources can be scaled down automatically. Let's get back to our advantages. Reliability is the ability to recover a system after failures and to continue operations. It's also a fundamental principle of a well-designed platform. Cloud, with its decentralized structure, naturally supports a reliable and robust infrastructure. Thanks to this decentralized structure, cloud allows resources to be deployed across regions worldwide. With such a global scale, even if one region experiences catastrophic events, other regions continue to operate without disruption. You can design applications to automatically leverage this enhanced reliability. In some cases, the cloud environment itself will be automatically moved to another region without any action required from your side. In this training, we will further discuss how Azure utilizes global scaling to ensure reliability. The next advantages of the cloud is predictability. Predictability in the cloud enables you to confidently move forward. Predictability is mainly focused on forecasting performance or cost. Performance predictability involves forecasting the resources needs to ensure the most efficient conditions for customer operations. Automatic scaling, load balancing, and high availability are just some of the cloud concepts that ensure performance predictability. If you suddenly need additional resources, elasticity allows you to deploy additional resources to meet demand and then scale down when demand decreases. Or if traffic is heavily focused on one area, load balancing allows redirecting some overload to less burdened areas. Cost predictability is about forecasting cloud expenses. Through the cloud, you can track resources usage in the real time, monitor resources to ensure their most efficient utilization, and apply data analytics to identify patterns and trends that help better plan resource deployment. The sixth characteristic of the cloud is security. Cloud offers robust security measures, including data encryption, identity and access management, and continuous threat monitoring. Leveraging the cloud allows organizations to tap into the expertise and resources of established providers, enhancing their ability to fend off cyber threats and adhere to industry compliance standards. Azure's advanced security features, regular updates, and dedicated security teams help safeguard sensitive data and applications, providing businesses with a strong foundation to mitigate risk and maintain a secure online environment. The 7 advantages is about cloud features supporting governance and compliance requirements. Cloud capabilities, such as predefined templates, guarantees that all deployed resources adhere to corporate standards and government regulations. Additionally, you can update all deployed resources according to new standards as they arise. Depending on your operational model, software patches and updates can also be applied automatically, simplifying management and ensuring security. And finally, the 8th advantages of cloud computing is manageability. Cloud management means managing cloud resources. In the cloud, you can perform various actions such as deploying resources based on pre-configured templates, eliminating the needs of manual setup, tracking resources health, and automatically replacing faulty resources, as well as receiving automatic alerts based on configured metrics to monitor real-time performance. Moreover, the cloud offers the various management methods that we'll discuss shortly. Now, let's explore the different types of cloud services and describe some use cases and benefits associated with each service. First of all, infrastructure as a service, IaaS, is the most flexible category of cloud services as it provides maximum control over cloud resources. In the IaaS model, the cloud service provider takes care of maintaining the hardware, network connectivity to the internet, and physical security. You're responsible for everything else, including installing, configuring, and maintaining the operating system, network settings, databases, storage, and more. With IaaS, you essentially rent the equipment in the cloud data center, but have full control over how to use that equipment. Platform as a Service, or PaaS, is a comprehensive cloud development and deployment environment with resources that enable the delivery of a wide range of cloud applications, from simple to sophisticated solutions. Similar to IaaS, PaaS includes infrastructure, server, storage, and network equipment, as well as the middleware, development tools, business analytics BI, database management services, and more. PaaS is designed to support the entire life cycle of a web application: development, testing, deployment, management, and updates. In PaaS scenario, you don't need to worry about licensing or installing patches for operating systems and databases. PaaS is a great choice for providing a fully functional development environment without the need to manage all the development infrastructure. And the third, Software as a Service, or SaaS, is the most complete cloud service model from a product perspective. With SaaS, you essentially rent or use a fully developed application. Common examples of SaaS implementation includes email services, financial management software, messaging application, and connectivity software. While the SaaS model may be the least flexible, it also offers the easiest way to get started. It requires minimal technical knowledge or experience for full utilization. Let's delve into a comparison of these three distinct cloud service types. Infrastructure as a service is like renting computer equipment from the cloud. You get to control how you use it, such as setting up different virtual machines for various tasks. Platform as a service, on the other hand, often finds application in software development. Here, the cloud service provider takes charge of platform management. For instance, you might utilize PaaS to build a web application without need to worry about underlying infrastructure. Moving to software as a service, this entails receiving a fully functional application ready for use. Think of it like accessing an email service or a collaboration tool such as Outlook, Salesforce, or MailChimp, where users pay based on a subscription model for the software they utilize. The shared responsibility model applies to all types of cloud services. The diagram you see on the screen illustrates different levels of responsibility depending on whether you use cloud services like IaaS, PaaS, and SaaS, or manage your own on-premises data center. Let's start with the right side of the diagram, which represents your on-premises network. Here, you're entirely responsible for everything, starting from the physical infrastructure. You're also responsible for your operating system, application, managing all users, and ultimately your data. However, as you transition to the cloud, the responsibility is shared between you and your cloud provider. In IaaS level, you rely on Microsoft for supporting the physical infrastructure. Microsoft also takes responsibility for its security, but you're responsible for everything that is not part of this physical infrastructure. When you move to PaaS, you no longer need to worry about the underlying operating system. Microsoft takes care of securing the operational system and some other management elements such as networking and application support, but you still need to contribute. This includes securing your applications and managing those who have access to your data. SaaS is a model where the cloud service provider takes the highest responsibility, and the user has the minimal responsibility. In a SaaS environment, you're responsible for the data you add to the system, the devices you allow to connect to the system, and the users you grant access. Practically, everything else falls under the cloud service provider's responsibility. They're responsible for the physical security of a data center, power, network connectivity, application development, and software updates. What I want you to take away from this table for your understanding is that your level of responsibility will vary depending on whether you use cloud services or set up equipment on premises. Additionally, you always take responsibility for your users' devices and data. Now, let's find an analogy from real life and talk about pizza. Yes, pizza. Our on-premises system is like making pizza at home, where you are responsible for all the ingredients, the table, cooking, etc. Yes, it's like ordering groceries to your house and make the pizza. But it's like pizza delivery, where we receive the pizza in a box at home, but we still need to set the table, get drinks, and clean up. And SaaS is like going to a pizza restaurant where the table is already set, food and drinks are ready, and they will even clean up after us. I hope this delicious analogy helps you better remember the shared responsibility model. Now let's recap what we covered in this session. We discussed the definition of cloud computing and cloud deployment models, where we compared private, public, and hybrid clouds to different transportation types. We also talked about the differences between capital and operational expenditures, defining that cloud technology leverage operational expenses. Furthermore, we discussed the 8 key advantages of the cloud. Then, we explored different types of cloud services and drew an analogy with pizza. With that, our first session comes to an end. We'll take a 10 minutes break to digest the information and move on to our second session. Enjoy it! Welcome to the second session after a break. In this session, we'll discuss the architecture components of Azure. You will learn about the physical organization of Azure, including data centers, availability zones, and regions. We will also explore the organizational structure of Azure, such as resources and resource groups, subscriptions, and management groups. Towards the end of the session, we will delve into various compute services available in Azure. So let's begin with the initial lesson, centered around the fundamental components of the architecture. This happens to be my favorite lesson due to my passion for travel. I will demonstrate you how Azure empowers you and your data to traverse the globe, enabling resources to find their place in any corner of the world. A region is a geographical area that contains at least one data center or multiple data centers located nearby and interconnected with low latency networking. The Azure platform automatically allocates and manages resources within each region, ensuring proper load balancing. When deploying a resource in Azure, you often need to select a region where it should be deployed. Certain services or virtual machine types may only be available in specific regions. Additionally, there are global Azure services that don't require choosing a specific region, such as Microsoft Entra ID, Azure Traffic Manager, and Azure DNS. Microsoft Azure currently comprises more than 60 regions worldwide, available in 140 countries. The second term related to our regions is availability zones. Availability zones are physically separated data centers within a single Azure region. Each availability zone consists of one or more data centers equipped with independent power, cooling, and networking systems. As a result, an availability zone acts as an isolation boundary. If one zone experiences an outage, the others continue functioning. Availability zones are connected through private high-speed fiber optic networks. To ensure resilience, each region supporting availability zones has at least 3 separate availability zones. However, some services may have limited support for availability zones. For example, some may only support availability zones for certain tiers, regions, or SKUs. Another crucial point to note is that most Azure regions are paired with another region within the same geographical area with a separation of at least 482 kilometers or 300 miles between them. This strategy enables the replication of resources across geographical zones, minimizing the risk of disruption caused by natural disasters, extensive outage, power failures, or network issues affecting an entire region. For instance, if one region from a pair is impacted by a natural disaster, services will automatically switch over to the other region in this pairing. Some examples of Azure region pairs include West US and East US, as well as Southeast Asia and East Asia, among others as mentioned on the slide. Since region pairs are directly connected and adequately distant from each other, they can be utilized to ensure redundant and reliable services and data. Besides the regular regions, Azure also offers sovereign independent regions for government organization. In other words, sovereign and independent regions are Azure regions dedicated to government entities, isolated from the main Azure environment. Azure government regions in the United States are physically and logically isolated from Azure networks for US government agencies and their partners. These data centers are operated by US citizens and undergo additional compliance checks. Azure government utilizes the same underlying technologies as Azure. This includes the services as IaaS, PaaS, and SaaS. Both Azure and Azure Government provide comprehensive security management capabilities, and upload Microsoft data protection commitments. Azure China represents a distinct sovereign region constituting an isolated Azure environment within China's borders. This exclusive Azure sovereign region in China is established through special collaboration between Microsoft and 21 ViaNet. Unlike other Azure regions, Microsoft doesn't directly oversee the operation of data centers here. Instead, 21 ViaNet autonomously manages this region. Now, let's proceed with the demo to explore our architectural landscape within the context of our global reach. Welcome to our first demo. In this demo, we will discover together Azure Global Infrastructure. For it, I will use the following website that you can see on my screen, so you can also discover it whatever and whenever you want. I will load the page and it will open me the global infrastructure experience. So what I have here, I have a 3D map of our globe that I can turn to discover different regions and geographies, as well as I have news updates related to our data centers and the legend on the left. If I open the legend, I will see different explanation of all symbols on my map. So, for example, this blue round, it's regions. I have also a square for zones, and even I have different sustainability projects for wind, solar, or mixed type of energy. And as well, I can open the filters to see my region according to different compliance measure or industry compliance. As well as I can discover different disaster recovery options available in each region. So if I close my legend and filters, I can turn the globe and to start seeing what are the different options available. For example, I have Central US, where I will see that this is a region with availability zones. Also, its location will be indicated as the year of opening and different products available in this region. So if I want to know more, I can just click on those options and to discover the details. For each region, I also have the data residency. So I will know that everything is stored in the United States. I will know that I have availability zones with 3 zones available, and also different disaster recovery options as cross-region disaster recovery and in-region disaster recovery. Moreover, I even have sustainability, as there is a Microsoft Circular Center coming soon. And at the end of the description, I will find different compliance standards and industry standards. So I can view them and to check that everything corresponds to my compliance needs. And also there is a link that helps me to learn about Azure compliance more in details. So it was Central US. What if we look in the center of Europe? So you know that I'm based in France, and here we are. So location is in Paris. For sure I will not find the detailed location as each region is highly secured. Also see the year of opening, different products available, and again, availability zone, disaster recovery, and compliance. If I look on my globe, we will see that Azure is huge service because we can find it in every corner of the planet. Even here in New Zealand, we can check that soon we will have one region that is coming, and also related articles to it. What I have as well here is the possibility to switch to the map view or to come back to my 3D globe, and we have a new feature that was added, that it's a virtual tour of a Microsoft data center that you can also take from this website. So hopefully you enjoy it and you will reuse the provided link in the future to discover more information about Microsoft data centers available to you. A resource is a basic standard building block, meaning any component in Azure, everything you create, provision, deploy, etc. is a resource. Virtual machine, virtual networks, databases, cognitive services, etc. All of them are resources in Azure. We'll talk about each of those things in more details on the next slides of the session. For now, I won't explain each one in details, but I will come back to that later when we discuss their meanings. Resource groups are simply resource grouped together. As the name suggests, when creating a resource, you need to place it in a resource group. While a resource group can contain multiple resources, each resource can only reside in one resource group at a time. Some resources can be moved between resource groups, but when moved, they will no longer be associated with the original group. Additionally, resource groups cannot be nested, meaning you can't place resource group B within resource group A, and we can't create a hierarchy between them. Resource groups offer a convenient way to group resources because actions applied to a resource group apply to all resources within it. Deleting a resource group will remove all resourcing within it. By granting or denying access to a resource group, you are effectively granting or denying access to all resources within that group. When preparing resources, it's recommended to carefully plan the resource group structure that best suits your needs. For example, if you're setting up a temporary development environment, grouping all resources allows you to undo the setup all related resources simultaneously by deleting the resource group. If you need to set up 3 different ways to access the compute resources, you are creating 3 different resource groups. It's a good idea to organize the resources by each access method and then manage access at the level of these grouped resources. Now, let's examine the management structure that contains our resource groups. To do that, we'll proceed to subscriptions. Subscriptions are the unit of management, billing, and scaling in Azure. Similar to how resource groups are a way of logically organizing resources, an account can have multiple subscriptions, but only requires one. In an account with multiple subscriptions, you can use subscription to configure different billing models and apply various access management policies. Azure subscriptions can be used to define boundaries for Azure products, services, and resources. Subscription boundaries come into 2 types: billing boundaries and access management boundaries. The billing boundary of a subscription determines how charges for use in Azure in the account are applied. You can create multiple subscriptions for different billing requirements. Azure generates separate billing reports and invoices for each subscription to help you organize and manage expenses. Additionally, Azure applies access management policies at the subscription level. You can create individual subscriptions that align with your organization structure. For example, within a company, specific departments could have separate Azure subscription policies. This billing model allows you to control access to resources used by users within their respective subscriptions. So, when thinking about subscription, remember that they serve as billing boundaries and regulate access. The last architectural element I want to discuss with you is management groups. As you already understand, resources are grouped into resource group, and resource groups are further organized into subscriptions. If you're just starting with Azure, this hierarchy might seem sufficient for organizing things. However, imagine you're working with multiple applications, several development teams in different geographical regions. With many subscriptions, an effective approach is needed to manage access, policies, and compliance. Azure management groups offer high-level coverage over subscription. You group subscriptions into containers called management groups and apply governance conditions to them. All subscriptions within a management group automatically inherit the conditions applied to the management group, similar to how resource groups inherit settings from subscriptions and resource inherit settings from resource group. Management groups provide enterprise-level management at large scales, regardless of subscriptions type. Resource groups can be nested within management groups. Important fact about management groups: one directory can support up to an incredible 10,000 management groups. Also, a crucial fact is that the management group tree can support up to 6 levels of depth. This limitation doesn't include the root level or the subscription level. Within this tree, each management group and subscription can have only one parent element. To better understand the structure, let's see how we can create a resource on the portal. Welcome to our second demo. In this demo, finally, we will see Azure portal. I would like to show you how to create a resource, and for this example, I will use virtual machine creation. To create the EVM, I can use multiple possibilities. I can search it here, or I can use my menu on the left, or I can just select recently used resource that is virtual machines. I will open it, and as for any resource in Azure, I have a button with a plus to create my resource. So I will create a VM together. When I'm starting a creation of any resource, I will have a project details that will be asked, involving subscription name and resource groups. So I will select my existing subscription, and after that I can create a new resource group for this demonstration. We can call it AZ-900 demo. After that we selected our resource group name, we can name our virtual machine. Also, we'll keep the same name for demonstration purpose, but if you're having doubts how to name your resources or what each field means, you can read the information provided in small boxes related to each resource. So no worries, Microsoft always helps you to learn more. So also sometimes we'll provide you the link that will bring you to Microsoft Learn if you're having doubts what is asked to fill inside. After I will select my region, I will use North Europe for example, because I'm based in France and I prefer always to use the region close to me and my user for the latency purpose. After that we have availability zones. As we mentioned before, we can have 3 availability zones, as well as I have 2 extra availability options, virtual machine scale sets and availability sets, that we'll discuss just later in this session. For the demo, I will not create extra availability options because we'll just see how to create a resource. After that, I have an image proposed here. I can use or recently used one, or recommended one, or even I can see all images accessible to me inside of Marketplace. So here I have powerful filters to search and select different VM, Windows or Linux one with different characteristics. For my case, I will just take a suggested one, and after that I will decide the size of it. The size will impact the cost, as you can see from the different proposed fields. I will go with the cheapest one for this purpose, and no worries, we'll come back again today regarding our sizes, so we'll discuss it again during our training. After that, I can create a username. I will use Contoso, for example, and I will need to provide a secret password for it. And after that, we can select different ports. Opening, we'll discuss it more in details during our networking session. For the creation, I will select just HTTPS. And no worries, if you forget to fill information about the ports, you can correct it later and we'll see how together in the next session. Also, I can provide information about the disks. I can select network that I would like to use. Also, you can see that it's creating automatically a new one for me. After that, we have management opportunities with information about the security features, monitoring one with alerts and diagnostics, advanced feature if you need some VM extensions or applications to use, and finally tags that are accessible to all Azure resources. And if I didn't specify all details about each field, it's because we'll speak about networking and monitoring and tags more in details during our training. Now it's just to show you how we can create a resource. And in the end, we have review and create, and we'll have a final validation of our resource creation. So if I forget something or I didn't provide the correct information, I will have a pop-up window saying like I did a mistake and I need to come back and verify it. Also, I will see at the end my final price. So we will pay just for what we use. It's a consumption-based model. And I see the price for each hour. So I know how much I will need to spend for this specific VM after I created it. I can review the full information I provided to verify that I have everything filled out correctly, and click on create, and we will see what will happen. As I click on create, I also have a pop-up window saying the deployment started, and after that the deployment in progress will appear. And here you will see the list of resources that will be created, their type and status. And what is the magic about creation of VM? And the fact that while we create a VM, we're also automatically creating multiple resources that just appear here. And after that, it will take approximately 1 minute to wait until everything is created and we can access our resource. Wonderful, as you can see, our VM is created. I can go to our resource, and here we are. We have all information about our VM provided. You can also modify the settings on the left side, or we can review a resource group where we have our VM. If I go to our resource group, I will see that we created so multiple resources via one resource creation. So I started the virtual machine creation, but also during this process I created my resource group, public IP address, network security group, VNet, network interfaces, and disk. And all these elements we'll discuss during our training. No worries, but it's just to show you the power of the cloud and the power of resource creation. As I created one resource, I added multiple during one task inside. Now, as we discover the portal, it was our first step in our learning of the Azure portal, let's come back to our presentation. Let's now explore different types of Azure computing. In this section, we will get to know Azure Computing Services. We'll explore different choices for computing, like virtual machines, app services, containers, and virtual desktops, which are displayed on the screen. We'll look at each of these resources separately in this session. So let's begin with the virtual machines, which we'll saw in our previous demonstration. With Azure Virtual Machines, you can create and use virtual machines in the cloud. They provide infrastructure as a service in the form of virtualized servers, and you can use them in various ways. Just like on a physical computer, we can configure any software running on a virtual machine. Azure Virtual Machines are an ideal choice if you need full control over the operating system, the ability to run custom software, and the integration of customizable deployment configuration. Azure Virtual Machines offer flexible virtualization capabilities without the need to purchase and maintain the physical hardware on which they run. However, within the IaaS offering, you still need to handle the setup, updates, and maintenance of the software running on the virtual machine. Virtual machines also have various capabilities that I briefly mentioned during our virtual machine creation, such as scale sets and availability sets. Virtual machine scale sets enable you to form sets of identical virtual machines while incorporating load balancing and management capabilities. Why might you opt for virtual machine scale sets? Primarily, they offer redundancy and enhanced performance. Applications often require distribution across multiple instances for reliability. As your application communicates through a load balancer, it distributes requests to various application instances. During maintenance or updates of one instance, the load balancer shifts customer requests to available instances, ensuring continuous services. For handling increased customer demand, you might need to scale up the number of application instances running your software. Azure Virtual Machine Scale Sets provide this essential management capability. They seamlessly manage applications spanning numerous virtual machines, automatically adjusting resource allocation and evenly distributing traffic. The advantages are apparent. Firstly, they're effortlessly created and managed, even for multiple virtual machines. Secondly, they offer high-tended availability and application resilience. Thirdly, they enable your application to adapt as resource needs fluctuate. Lastly, they're equipped to handle substantial scales, with some sets accommodating up to 1,000 virtual machine instances. And finally, virtual machine availability sets are another means to create a more resilient and highly available environment. Availability sets ensure that virtual machines are placed in groups that follow specific update and fault domains, preventing the loss of all virtual machines during a network or power failure. Availability set achieves this by grouping virtual machines in one or two ways: update domain and fault domain. The update domain contains virtual machines that can be rebooted simultaneously. This allows you to apply updates knowing that only a few update domain grouping cannot be in maintenance mode simultaneously. All machines in one update domain will be updated. And the second element is the fault domain. The fault domain groups virtual machines based on a common power source and network switch. By default, availability sets split virtual machines into 3 fault domains. So even if power or network fails in one domain, others stay safe. This method is cost-effective too. You pay only for the virtual machines you use. Now let's go back to the portal to learn how to set up a virtual machine scale set. In our third demo, we will see how to create virtual machine scale set and use it. So to create it, I can search or select a recent service that I use. If I use my search, I can also review the documentation provided. It's a very practical option because each documentation will bring me to the information how to use this feature, and it will bring me to the Microsoft Learn website. So if I would like to create, I will select Virtual Machine Scale Set. Again, as we did with the resource creation of our VM, we can click on plus create and provide the information as before about subscription resource group. This time I will select the resource group that we created in our previous demo. I will also provide a name. So I will again AZ-900 demo. I will clip it in the same region close to me. Also very practical. I can integrate my virtual machine scale set with different availability zones provided here. And after that, I can select different orchestration mode, flexible or uniform. As for VMs, I have different security types provided. I will go with default one, and I can select an image. You remember during the VM creation I go with Windows, now I will select the Linux one. We will select the sizes. Again, when I select the size, I have information about the price. And after that, we can decide how we will use this virtual machine scale set and how we will protect it. Is it password or the public key? I can, for example, go with the password. I will use the same one, Contoso, provide a secure password, make attention that I remember it, and they're the same. And after that, we'll have multiple options as we had before for our VM. What is the most interesting for me? It's the possibility of scaling that we discussed. We spoke about different benefits, about elasticity, the automatical scaling, and about scaling itself as the benefit of cloud computing. And here we have very interesting flexibility, let's say, because we can decide how many instances we would like to have at the beginning, and if we would like to scale manually or automatically. For automatical scaling, we can select custom option and decide that, for example, I don't want that I have less than 2 instances running, and the maximum number will be 9. And after that, I will select my rules. So I can say if the CPU going more than 75%, for 10 minutes, I will increase my initial count, so my 2 instances, by 1. So we'll have 3. If I have, for example, my CPU going for 75% for 20 minutes, it means I will have plus 2 instances, so it will be 4. And also I can scale in. If, for example, my CPU is less than 25%, I can decrease my instances. I have 1. So this way I also save my cost because I don't using so many resources if I don't need them. So by activating it, it's very practical. Let's say if we have Christmas or you have like a Black Friday and you have too many visitors coming, so you can automatically increase your workload, as if you don't have so many customers, for example, Monday, you can decrease your workload. It's how we can set up this automatical scaling. And after that, if we go, we can review different policies, protection, advanced settings, and then tags. I'm not showing all these options because we will discuss them later today. So the most important, we saw how we can set up virtual machine scale set and how we can scale it automatically. And after that, we just need to create it and wait until our virtual machine scale set is created. And don't worry, you can always adjust your scaling options. So it means after the creation, I can also come back to manual scaling, as I can modify the policy that I created for it. So I can modify and decide, for example, to set up 10 instances as a maximum and 1 as a minimum, and etc. Thank you for your attention. In this demo, I will not wait until it's created because we already saw what is going on. And we can come back directly to our slide as we saw together how we can deploy a virtual machine scale set and also to use automatical scaling inside. Thank you for your attention. Let's go back to the slide. Azure Virtual Desktop is a virtualization service for desktop systems and applications that operates in the cloud. It allows you to use a cloud-hosted version of Windows from any location. Azure Virtual Desktop works on various devices and operating systems, and it's compatible with applications that can access remote desktop or most modern web browsers. Azure Virtual Desktop provides centralized management of user desktop security. You can enable multi-factor authentication to secure user logins. Additionally, you can protect data access with detailed role-based access controls. When using Azure Virtual Desktop, data and application are isolated from local hardware. In fact, the desktop and application run in the cloud, reducing the risk of sensitive data remaining on personal devices. Moreover, user sessions are isolated in single or multi-sessions environments. When it comes to virtual machines, they are a smart choice for cost saving as they eliminate the need for physical hardware investment. However, they do have a limitation. Each virtual machine can only run a single operating system. Containers, on the other hand, offer an excellent solution when you require multiple instances of an application to operate on a single host computer. The Azure Container Instances service offers the easiest method to run containers within Azure, all without the complexities of managing virtual machines or utilizing additional services. The service falls under the platform as a service model. With Azure Container Instances, you can deploy your containers and the service will take care of launching them. The second key element on the slide introduces Azure Container Apps, a fully managed environment tailored for running microservices and containerized application on a serverless platform. This platform enables the execution of application code packets into any container, and it remains open-minded about the runtime or programming model you choose. With container apps, you harness the benefits of running containers while shedding the burdens of managing complex cloud infrastructure and container orchestration services. Lastly, the Azure Kubernetes Service, AKS, stands out as the quickest route to initiate the development and deployment of purely cloud-native applications, offering built-in pipelines that take you from code to the cloud and comprehensive security features. Azure Kubernetes Service streamlines the deployment of a managed Kubernetes cluster within Azure, elevating the operational responsibilities and shifting them to Azure. This service manages vital tasks, including health monitoring and maintenance. Quite a bit of new information, isn't it? Let's do a quick recap and compare the compute options. In the case of a virtual machine, we have a cloud server supporting Windows or Linux. A virtual desktop provides capabilities for a Windows Cloud desktop. Containers, on the other hand, offer an environment for running microservices. As for their usage purpose, virtual machines are typically used when migrating to the cloud, virtual desktop for connecting user to desktop application, and containers for scalability. Each service has its interesting advantages. Virtual machines include full operating system package. Virtual desktop can support multiple users simultaneously, while containers can reside on one operating system of the virtual machine server. If you need to deploy an application in Azure, you can first consider virtual machines or containers. Both virtual machines and containers offer excellent solutions for deployment. Virtual machines provide maximum control over the hosting environment and precise configuration. They can also be the most familiar way to deploy if you're just starting with the cloud. Containers, with their isolation capabilities and individual management of different aspects of the deployment, can also be a reliable and efficient option. It enables automatic deployment from GitHub, Azure DevOps, and any Git repository to support continuous development. Good, we have covered containers and virtual machine. Now, what's about application deployment? Azure Functions are event-driven serverless compute resources that don't require the management of virtual machine or containers. When building an application using virtual machine and containers, these resources must be running for the application to work. With Azure Function, an event triggers the function, reducing the time to prepare resources when there are no events. Azure Functions are suitable when you care only about the code for the service, not the underlying platform or infrastructure. They are used when a simple and fast action, which completes in a few seconds or even less, needs to be performed in response to an event, such as a REST request, timer, or message from another Azure service. Azure Functions automatically scale on demand, making them ideal for cases where requirements change. The Azure Function Service executes code when triggered and automatically deallocates resources after the function's execution. Azure App Service provides a dependable hosting solution for deploying applications within Azure. It allows you to concentrate on constructing and upholding your application, while Azure handles the availability of the underlying environment. Functioning on an HTTP-based model, Azure App Service serves as a platform for hosting web applications, RESTful API interfaces, and mobile backends. This service boasts multilingual support encompassing .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. Additionally, it accommodates both Windows and Linux environments. Notably, App Service introduces the capabilities of Microsoft Azure into your applications, including security features, load balancing, automatic scanning, and automated management. Beyond that, it extends its offering to DevOps functionalities such as continuous deployment from platforms like Azure DevOps, GitHub, Docker Hub, and other sources. App Service delivers a spectrum of features, including package management, staging environments, and custom domains. These resources are dictated by the App Service plan under which your apps operate. We have reached the end of our second session. Let's recap what we have covered. We started by exploring the regions and availability zones, followed by a deep dive into resources, resource groups, subscriptions, and management groups. We then delved into various options for virtual machines, including the machines themselves, their scale sets, and availability sets. Furthermore, we compared different types of compute services, such as container instances, virtual machines, and virtual desktops. Finally, we discussed services for application deployment. With that, we conclude our second session. Thank you for your attentive participation. We'll now take a 10-minute break. See you shortly. Welcome back! In our third session, we will discuss virtual networks. We will cover the following topics: the purpose of Azure Virtual Networks and Azure Virtual Subnets, VPN gateways, express routes, and finish with Azure DNS. So let's begin our dedicated networking session. Azure Virtual Networks and Subnets facilitate seamless communication among Azure resources, including virtual machines, web applications, and databases. This architecture also fosters connectivity with users across the Internet and local client computers. These virtual networks can be visualized as extensions of your on-premises network, interconnecting various Azure resources. Moreover, in the context of networking within Azure, network peering is a significant feature. Network peering enables the linking of different virtual networks, creating a private connection for communication between them. This connection is similar to a local network extension across virtual spaces. By establishing network peering, you can seamlessly share resources, such as virtual machines or databases, across distinct virtual networks, ensuring efficient and secure communication. Within Azure Virtual Networks, two types of endpoints play crucial roles in data exchange: public and private. Public endpoints possess public IP addresses, accessible from anywhere globally. Private endpoints, however, are confined within the virtual network and are assigned private IP addresses within the virtual network's IP address space. When configuring an Azure Virtual Network, a private IP address range is defined, utilizing either public or private IP address ranges. This IP address range remains confined within the virtual network and lacks internet routing capabilities. Further division of this IP addresses range into subnets allows specific portion of the range to be allocated to distinct subnets. For enhanced security and control, Azure Virtual Networks incorporate network security groups. These groups act as containers for numerous security rules governing inbound and outbound traffic. By evaluating factors such as source and destination IP addresses, ports, and protocols, these rules dictate whether to permit or deny traffic. This fine-grained control ensures the traffic flows as intended, bolstering the network's overall security posture. As we delve into the specifics of Azure's networking capabilities, let's also explore the practical implementation of network security groups within the Azure portal. Welcome to our demo. In this demo, we will review the network access. For this, let's go to the resource group that we created in our VM creation demo. So here in my resource group, I have network security groups that were created automatically. If I will open them, we will see different inbound and outbound security rules. Inside of inbound security rules, we have 3 rules that were created by default and one that was created because I decided to open HTTPS protocol. Also, I have outbound security rules that were added automatically. If you look on these rules, we have a priority. After that, we have a name. For example, allow VNet inbound traffic. We have a port from any port. We have also any protocol, source virtual network, and destination virtual network allow. So it means that the traffic from VNet to VNet is allowed by default. The same we have for outbound traffic that will allow from VNet to VNet, and here we have allow. So those rules were created by default, and one with priority 300 were added because I decided on creation to open HTTPS protocol, and it has priority 300. So less the priority, less the number is higher, more priority we have. So it means if I will create another rule with 200 as a priority number, it will be more important than the rule with the number 300. Don't forget it, for example. Lower is our number, higher is priority. Now, if we would like to connect to RDP with our VM tool, so if you would like to open our remote desktop, it will be very difficult and impossible because we don't have a specific port open. So let's see what will happen if I will decide to connect and how we can create this connection. For it, I will go to our VM, I will select connect, and I will download it an RDP file for the connection. Okay, now let's open our RDP file and select the connection, and you see it's asked if I would like to connect. As the protocol is not open, I should have refused, so let's try and we will see that it will not work. So we see that we have an error message because the access is not enabled. To give an access, what we'll do, we will create a new security rule inside of our NSG's rules. So I'll come back and we will add an extra inbound rule, and we'll decide that this time we will use our RDP protocol. So the service RDP, we will allow the traffic, and if we want to have the biggest priority, we will put, for example, another number, or we can keep it 310, and after that add this protocol. For sure I will have a message saying like this port open my access to the internet. I also have this highlight symbol because it's important to notify me that I'm giving access to VM over the public internet. So let's come back now to our VM and to try to connect this time as we open the protocol. We will come back again. We will need to download again our RDP file. We'll open our file and we will connect to our remote desktop protocol. I use a Contoso and I provided the password. And after that, again, it will ask me if I'm okay to connect. And here we have a magic. I can open my remote desktop protocol with my Contoso name. And now we learn that we can use the network security rules to open different ports and to have access to our remote desktop and to connect to it thanks to our VM creation and also different network security rules that we added together. Thank you for your attention. Let's come back now to our presentation. Imagine living in a glass house where everyone can see what you're doing. Not a great feeling, right? Well, using the internet without a secure VPN is a bit like that. So what is a VPN? A VPN, or virtual private network, is like a secret tunnel on the internet. It keeps your online information private and safe. It's like putting special tinted glass on your glass house. You can see out, but no one can see in. When you use a VPN, your data travels through this secure passage to special VPN servers. No one, not even your internet service provider or government, can snoop on your data. The VPN also masks your real device's addresses and use its own address instead. This provides a shield for internet use, even on Wi-Fi networks. A VPN works somehow like building a secret road inside another road. It's useful for linking private networks over the big public internet. Any data sent on the secret road is locked up with encryption, a protective layer that keeps your information secure. Every network can only have one special entry point for this secret road, but this entry point can connect to various places like other networks or your computers located in different spots. In Azure, there exist dedicated VPN gateways. These gateways ensure that data can move securely between Azure networks and your own computers, even when they're far apart. These gateways also enable different Azure networks to communicate securely with one another. In essence, a VPN is your personal concealed pathway on the internet, ensuring your online activities remain private and secure, much like the walls of a glass house fitted with tinted windows. ExpressRoute is an Azure service that allows you to create private connections between Microsoft data centers and your on-premises infrastructure. ExpressRoute connections do not go through the public internet, providing enhanced security, reliability, and low latency performance compared to regular internet connections. This means as well that ExpressRoute connections offer greater security, reliability, and speed with reduced and predictable latencies compared to standard internet connections. In some cases, using ExpressRoute for data transfer between on-premises devices and Azure can significantly reduce costs. ExpressRoute enables connection to Microsoft Cloud services, such as Microsoft Azure and Microsoft 365, and connects offices, data centers, or other locations to the Microsoft Cloud. Each location has its own ExpressRoute service. You can enable ExpressRoute Global Reach to facilitate data exchange between on-premises sites by connecting them through your ExpressRoute circuits. For example, if you have an office in Asia and a data center in Europe, both connected to Microsoft's networks through ExpressRoute, you can use ExpressRoute Global Reach to connect these two locations so they can exchange data without going through the public internet. In summary, the main difference between a VPN gateway and ExpressRoute lies in the nature of the connection and the level of performance and security they offer. A VPN gateway uses the public internet to create secure connections, while ExpressRoute provides a dedicated private connection with higher performance and security features. The choice between these options depends on your specific networking requirements, data sensitivity, and performance needs. Moving forward from discussing the difference between VPN gateways and ExpressRoute, let's now explore the capabilities of Azure DNS. DNS, or Domain Name System, can be described as a phone book. It's translating human-readable names to computer-friendly addresses. Azure DNS, or Azure Domain Name System, is a hosting service for DNS domains that provides name resolution by using Microsoft Azure infrastructure. Azure DNS operates as a cloud-based solution, offering the ability to host and manage DNS domains, also known as DNS zones. These zones serve as collections of DNS records that handle the translation of human-readable domain names into machine-friendly IP addresses. By entrusting your domain to Azure's infrastructure, you gain the convenience of overseeing your DNS records using familiar Azure tools, APIs, and credentials. The payment structure mirrors other Azure services, where you are billed based on your usage. Azure DNS seamlessly integrates with your Azure resources, facilitating automated updates to DNS records based on changes within Azure, such as deployment or modifications to resources. When you relocate a web application to a different location, the associated Azure DNS record is automatically adjusted to reflect the change. In Azure DNS, a global network of Azure DNS serves hosts DNS domains. This architecture ensures both resilience and high availability. To optimize query processing, speed, and availability for your domain, the network is designed so that each DNS request is directed to the nearest available DNS server. In summary, Azure DNS provides a dynamic platform for hosting and managing DNS domains. It leverages the convenience of Azure's ecosystem, the efficiency of automation, and the assurance of high availability, contributing to a smoother and more reliable online experience for your users. And Azure DNS concludes our first part of the training and our third session. Let's recap everything we have learned in this first part. We started with the first session and learned about the fundamental principles of cloud technologies. We familiarized ourselves with various types of cloud deployment models and discussed the differences between capital and operational expenditures. Next, we described the different advantages of cloud services and explored the three different types of cloud services as IaaS, PaaS, and SaaS. We wrap up the first session with the concept of shared responsibility. Moving on to the second session, we examined different components of the architecture, such as regions, availability zones, subscriptions, and resource groups. We also delved into various types of compute options like virtual machines, containers, and virtual desktops, making comparisons between them. Towards the end of our second session, we discussed application deployment. In the third session, we focused on Azure Virtual Networks, Azure Virtual Subnets, VPN, ExpressRoute, and Azure DNS. Thank you so much for joining us for this session. Wishing you a fantastic learning experience and see you soon in the second part of our training dedicated to Azure fundamentals.